So each of these classes has a unique network and host portion. Class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has three network portions and one host portion. Class D and Class E have all network portions, no host portions in them. So as you're going down the line, network portions are increasing in number. Class A has one network portion, Class B has two network portions, Class C has three network portions, Class D and Class E have all network portions. But what are these network and host portions? What do they signify? Okay. To understand that, let's take the example of Class C first, which has three network portions and one host portion. Okay. So in Class C, the first private IP begins at 192.168.0.0. That's the range of private IP, if you remember. It starts from 192.168.0.0 to 192.168.255.255. So if you take the example of Class C now, as mentioned earlier, oh, one second. Anyways, so as mentioned earlier, the first IP is at 192.168.0.0. Okay. After that, now out of this 192.168.0.0, the first three portions are network portions. Last portion is the host portion. Okay, in Class C. So after 00, you have 01, 02, 03, 04, 05, 06 goes up to 0255. After 0255, you have 1011, 12, 13, 14, 15 goes up to 1255. Then you have 2021, 22, 23 up to 2255. Now, what I mean by network and host portions is, as long as the network portion is same, it indicates that all of these IPs belong to the same network. And each change in the host portion indicates a new host in that same network. So this could be my Wi-Fi router, this could be my phone, this could be my laptop, this could be my smartwatch. So as such, I can connect a maximum of from 00 to 0255, a total of 56 devices. Okay. So let's take it roughly as 255. Okay. And when the zero over here in the network portion changes to one, the network divides over there. So now these IPs belong to a completely different network. They cannot communicate with this network. Okay, so even if you bring a device like 1.1 and physically connect it to this network in this network, it still will not be able to communicate because it belongs to a different network portion. So devices belonging to the same network portion can only communicate among themselves. They cannot communicate with other network devices. So in Class C, where you have three network portions and one host portion, in each network, you can connect a maximum of 1 to 255 devices. Okay. Similarly, over here as well, in 192.168 one dot network, we can connect a maximum of 255 devices. In two dot network, a maximum of 255 devices. So in each Class C network, we can connect a maximum of 255 devices. Is that clear? Wahab, Wamsi,
Yes.
right? Moving forward, when you talk about Class B now, Class B has two network portions and two host portions. Okay, so the first private IP in Class B starts at 172.16.0.0. After 00, you have 01, then 02, then 03, then 04, goes up to 0255. After that, you have 10, 11, 12, 13, goes up to 1255. Then you have 20, 21, 22, 23, 24, goes up to 2255. Like that, the cycle keeps on repeating, and somewhere down the line, you would have 2550, 2551, 2552, goes up to 255255. Now, once both these octets are filled, this 16 now changes to 17. So same logic, as long as the host portions are changing, it just indicates a change in the host. This could be my router, my smartphone, my smartwatch, my smart TV, my other laptop, whatnot. Okay. So as such, I can connect from 00 to 255, 255. Okay. And when 16 changes to 17, whenever there's a change in the network portion, the network divides over there. So this is the last IP in that network. So as such, from 00 to 255, 255, we can connect a maximum of, since there are two octets, 255 into 255, which gives me an approximate value of 65,535. So in each Class B network, we can connect 65,000 devices approximately. In Class C, we could only connect 255, but in Class B, we can connect 255 into 255 since you have two host portions. And in Class A, since you have one network portion and three host portions from 10.0.0.0 all the way up to 10.255, 255, 255, all of these belong in the same network. When 10 changes to 11, that indicates the end of the network there. So since it has three host portions, we can connect a maximum of 255 into 255 into 255, the largest of all. Okay. So basically, network portion gives identity for the network, Host portion gives you identity for the host in that network. So in class C, as mentioned, in each network, we can connect 255 devices, not more than that. In class B, 255 into 255 devices. And in class A, 255 into 255 into 255, the largest of all. Class D and Class E do not have any host portions in them, guys. All of them are public IPs. They're used for special purposes, okay, for research and development, for government portals, for military services. All those organizations use Class D and Class E. They're not given to the general public like us. Okay? So that is the relevance of each class, guys. Okay. When you talk about classes, it's only important when you talk about private network IPs. Nothing for public IPs. Public IPs in any class are the same. They're for internet connection. Private IPs are what are different from each class. Okay. Class C private IPs can be used to connect only 255 devices in each single network. Class B, 255 into 255. Class A, 255 into 255 into 255. Okay. Exactly. Wahab, Wamsi, any questions regarding this? Yeah, Wahab, you were saying something.
No questions.
Okay. Vamsi, any questions on your end? Okay. Moving forward. Now, this is about classes, guys, and the networks. Now, again, there's one more important thing to discuss. So if I open up my command prompt here, and if I type ipconfig to check my private IP, you can see I've got some information here. So I see my private IP here. Under my private IP, I see something called subnet mask 255.255.255.0. Okay. So what is the subnet mask? What is this default gateway? Let's talk about that. So for us humans to understand which IP belongs to which class, we have network and host portions. But how does a computer understand that? So what a computer does is it assigns the network portions with the value of ones and host portion with the value of zeros. Okay, so it helps determine network and host ranges within an IPv4 address. Okay, so when you talk about class A, it has one network portion and three host portions. So in network portion, you put all ones in the octet. And in host portion, you put all zeros. And when you convert that from binary to decimal, all ones is 255, all zeros is simply zero. So for class A with one network portion and three host portions, subnet mask is 255.000. For class B, with two network portions and two host portions, subnet mask is 255.255.000. And for class C with three network portions and one host portion, subnet mask is 255.255.255.0. And if you notice over here, the IP I'm getting is a class C private IP. And since it's class C, the subnet mask is 255.255.255.0. That's the same subnet mask that I see here for class C. Okay, so a subnet mask is basically for a computer to understand which IP belongs to which class. And once it knows which class it is belonging to, it knows how many devices it can connect to. So with the subnet mask, my computer knows now, okay, in this network, I can only connect maximum to 255 devices, not more than that, because this is a class C IP. Okay, so it understands the range of the network, it understands which class it belongs to from the subnet mask. And then default gateway, this is basically a fancy name given to your Wi-Fi router. Okay, your router acts as a gateway between the public network and the private network. If I show you this image again, remember, this is a Wi-Fi router here. And whenever any of these devices wants to communicate with the internet, they have to send the packet to the Wi-Fi router first. So this is acting as an intermediate device between the private network and the public network, a gateway between the private and public, hence the name default gateway. So when any of these devices wants to communicate to the internet, they have to send the packet to the default gateway. And then from there, it goes to the internet, hence the name default gateway for it. So your router gets the first IP in the network, and that is called the default gateway. That's it. Okay. Moving forward now, let's talk about how do you assign a private IP. So public IPs are given by ISP anyhow, but private IPs are in our control. So the main question is how can we modify our private IP or how do we assign our private IP? So there are two methods for this, guys. Method one, you can change it manually from the control panel, or method two, you can get an IP assigned from a DHCP server automatically. Okay, and we're going to discuss both the methods today. So firstly, right now, my private IP that I'm getting is 192.168.0.3. And if I had to change this, method one is from control panel. So you can go to control panel, network and internet, network and sharing center, change adapter settings, right click on the adapter, go to the properties, IPv4 properties, and then assign the following IP. So if I show this practically, go to control panel, In control panel, go to network and internet. In network and internet, go to network and sharing center. In network and sharing center, go to change adapter settings. And then you right click on your adapter, go to properties. And here you go to IPv4 properties. And here you can see there's an option to assign an IP. Right now, I'm getting an IP address automatically. So I'm getting it from my DHCP server. But if I had to assign an IP manually, I have to select the second option here and assign the IP. So I can type 192.168.0.100. Subnet mask for this is class C. So subnet mask is 255.255.255.0. Default gateway is your router's IP, 192.168.0.1. So these are the pieces of information you're supposed to assign here. Along with that, you also need to give something called DNS server address. Now, don't worry, what is a DNS server? I'm going to talk about that in a bit. But just in case, if you don't know what to enter here, you can go to your browser. And in your browser, you can just simply search for Google DNS server IP. So when you search over here for Google DNS server IP, that will provide you two IP addresses. One is 8.8.8.8 and the other one is 8.8.4.4. Okay. And now you can enter any of those IPs here. 8.8.8.8 or 8.8.4.4. Okay. And once all of these pieces of information are assigned here, if you click on OK, that will change your IP now. So this will change my IP from 0.3 to 0.100 now. Okay. But I don't want to do that because that will disconnect our meeting now. So again, but this is the method, guys, to assign a private IP to any system. So in the olden days, when you didn't have a DHCP server, this was the job of the network admin to go to every system in the network and assign a private IP this way. Okay. But if it's a small network, that's fine. But if it were a larger network, like thousands of devices, then it would be a bit troublesome. It's a kind of a hectic task. So that is why we have something called a DHCP server, which can automatically assign an IP to every system in the network. Okay. And that is run with something called the DORA process. Okay. So again, in your network, when you have a DHCP server, it has a pool of free IP addresses. And from that pool, it automatically assigns any new device connected to the network with a private IP from the DORA process. So in our home networks, guys, our Wi-Fi router itself is the DHCP server. Okay, it can act as a DHCP server and the Wi-Fi router at the same time. Okay, but let's talk about this DORA process now. What is this DORA? Oh, someone exiting the session continuously. Anyways, yeah. So let me draw this out, guys, and explain what a DORA process is. So as mentioned, in our home network, the Wi-Fi router itself acts as a DHCP server. So if this is my DHCP server here, let's say, it's the same device as my Wi-Fi router. So DHCP server or my Wi-Fi router is the same device. Okay. And it gets the first IP in the network, 192.168.0.1. Okay. And it can have a pool of free IP addresses now. Pool of free IPs. Okay, so it has the IPs now pooled from 192.168.0.2, 192.168.0.3, then 0.4, 0.5, goes all the way up to 0.254. Okay, 255 is never used, guys. It's called a broadcast IP. So that IP is never used to assign an IP to any system. Okay, so whenever there's a device connected in the network, okay, and when it is selected on that option, obtain an IP address automatically. So when it is selected on this option here, this first option, obtain an IP address automatically. What it does is basically it starts sending a broadcast signal. Okay, so again, let me explain that in a minute. So basically, whenever there's a device in the network, your DHCP server assigns an IP to these devices automatically with the DORA process. So whenever an IP is assigned with the DORA process, so let's say if this is getting the IP 0.2 and if this gets 0.3, those IPs are now removed from the pool because they should not be assigned again to other devices, right? So now the new pool begins at 0.4 instead. So now this becomes 0.4 and this becomes 0.5. Okay. Now let's say we bring one more device in the network. So let's say there's another device here, a new device. So the first thing that this device does is it sends a broadcast signal. So as mentioned, there's an IP called a broadcast IP. 192.168.0.5, 0.255, sorry, my bad. Okay. So whenever a packet is sent to that IP, guys, that packet is now sent to every device in the network. So that's called broadcasting from one device to every device. And this packet is called the discover packet. So it is basically trying to figure out who the DHCP server is. It's asking each system in the network, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? So when it reaches the wrong devices, they just ignore that packet. They don't respond to it at all. Okay. But when it reaches the correct DHCP server, that server now responds back saying, hi, I am the DHCP server in this network. You have discovered me, and I can now offer you an IP address. So in return, it offers a free IP offer next IP, which is available, which is 192.168.0.4. So for that offer now, your client says, hi, thanks for offering me that IP. I request you that you allocate that IP to me. Since you have offered that IP, give that IP to my system. Do not assign it to anyone else. And for that request, in return, your DHCP server acknowledges it. It sends a confirmation saying, hi, I've got your request. I acknowledge that request. And with this acknowledgement, I confirm that you get this IP. Okay, and with that acknowledgement, this device gets the IP 192.168.0.5, oh sorry, 0.4, and that IP is now removed from the pool here. Okay, so now the new pool begins at 0.5 instead. Okay, so this whole process of discover, offer, request, and acknowledgement is the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. And all of this happens very quickly, guys, in a split second, I would say. So if you have an Android phone, whenever you connect to a Wi-Fi network, so let's say when you connect to a new Wi-Fi router or something, when you enter the correct password and when you click on connect, for a very short duration, you see a message obtaining IP address. Not sure how many of you have ever observed that, but during that message obtaining IP address, your phone is performing the DORA process with the router and trying to retrieve an IP. Okay. So again, all of this happens very quickly, guys. So whenever you connect to a Wi-Fi router, the first thing that happens is a DORA process. And from that DORA process, your system gets an IP automatically. So no matter how many devices are connected to your network, all these devices perform DORA first and get an IP automatically. So in this way, the network admin doesn't have to worry about assigning an IP to each system manually. DHCP server will handle it. Okay. Is that clear? Everyone? Wahab, Wamsi, any questions? Do you want me to read?
Yes. Yes.
Cool. Moving forward, now there is the next topic called DNS servers. So if you remember, when we were trying to assign an IP manually, it was asking for DNS server address. And we specified something like 8.8.8.8 or 8.8.4.4. So what are these IPs and what is a DNS server? So to explain about DNS server, it is basically like your internet's phone book, guys. Okay. So what I mean by that is now in your phone, you have an application called Contacts, right? So in that Contacts, you have a series of contact names saved with linked with contact numbers. Now, whenever you want to dial up a certain person's number, let's say, for example, you want to call my phone. So again, since we humans are terrible at remembering long numbers, we save it with contact names. So you can save it as the contact name as Shoaib or cybersecurity trainer or cybersec guy, whatever it is. Okay. But when you dial a number from your SIM card to my SIM card, your SIM card has no relevance on what you save my name as in your phone. The only thing it needs to form the connection is its own 10-digit SIM card number and my 10-digit SIM card number. So the connection here is being formed on the 10-digit SIM card numbers. Okay, your 10-digit phone number and my 10-digit phone number. It does not matter to the SIM card what you save my name as. It is only for your remembrance to again recognize who this number belongs to. Similarly, when you go to a browser and in the browser, when you search for www.google.com, this is called a domain name. Okay. And this domain name is not something that you can connect on the internet. Your system's browser doesn't understand this language actually. So when it wants to connect to google.com, this google.com is hosted on a server somewhere. It's put up on a server somewhere. And that server has a public IP. So what your browser actually needs is the public IP for that server. Okay. But since it doesn't know that information, it contacts something called a DNS server. A DNS server is basically a server containing the linking between every domain name and every IP address on the internet. Okay. So when you search for google.com, that request first goes to your ISP. They might have a DNS server here. And in that DNS server, they have linking. between every domain and every IP. So google.com is linked on so-and-so IP. Bing.com linked on so-and-so IP. YouTube linked on so-and-so IP. Shro linked on so-and-so IP. So basically every domain has an IP address to it, and the DNS server has a record translating human readable domain names into IP addresses. So when I search for google.com, that request first goes to a DNS server. From there, it gets to know what the IP for Google is. And from that IP, it reaches the correct server. Okay. So just like how your contact book was linking contact names and contact numbers, DNS server links domain names and IP address numbers. Okay. So when I hit google.com and when I hit enter, I'm able to reach the correct server because of a DNS server. If there were no DNS servers, your browser would never have understood what google.com means actually. Okay. And if I show you an example for this, I can open up my command prompt. And in my command prompt, I can run a command called ping. Ping is a command to check for connectivity actually. It sends some packets to a target server and checks if those packets are responding back on that. So if I type ping www.google.com, now my device starts sending some packets to Google. And in return, you can see it's getting a reply back. And when you're getting a reply back, you can see I'm getting a reply from an IP address here, 172.217.163.196. And if I copy that IP now, and if I go to my browser, and if I paste this IP here in my browser, and if I hit enter, you can notice it loads google.com actually. So this is the exact IP for the server of Google, but we don't have to remember this because we have a DNS server now. So that DNS server links this domain name with this exact IP. So now we don't have to remember this IP address. We can just remember the name, all thanks to a DNS server. Is that clear, guys? What a DNS server is? Any questions? Vamsi, Wahab?
No,
Right. Wahab, any questions on your end?
no.
Perfect. So yeah, this is about a DNS server, guys. Again, nothing further. This is what we discussed in the earlier sessions, actually. So there's a few bonus topics as well. Again, an assignment for you, if possible. What I want you to do is I want you to find out if there are any special IPs, actually. So there are two kinds of special IPs. One is called as loopback and one is called as APIPA. So what I want you to do is I want you to figure out what this loopback and APIPA IPs are and give me the answers by next session. Okay. So again, I've described them anyhow over here, but I want you to do some more research on this on the internet and figure out what special IP addresses are. Okay. So yeah, that's it. Nothing further, guys. We have one more topic as well called CIDR. Not so important. I'll be covering this in our Linux commands class anyhow, so you can ignore this. But as mentioned, a small assignment for you is to figure out what are special IPs. So there are two categories of special IPs and IPv4, and I want you to figure out what those are. That's an assignment for you over the weekend. Okay, what is loopback and what is APIPA? And I want you to give me the answers on Monday regarding these things. Okay. So yeah, that's it, guys. Nothing further. This is all we learned about networking in the earlier sessions. Quite important, quite fundamental concepts. Okay. And from Monday, from again this is the only last 6 a.m. class. From next class onwards, you can only join at 8 a.m. Indian Standard Time. So today, please rejoin at 8 a.m. where we continue the Linux commands. Okay. So again, from next class, you only have one session at 8 a.m., no more 6 a.m. sessions. Okay, so this is what I had to cover for you because again, as mentioned, we covered this earlier, you weren't there. So I had to take up some backup sessions for you guys. Okay, so yeah, that's it. Nothing further for our session today, guys. We can exit here and we can connect back again in 1.5 hours for Linux commands. Okay, any questions, Vamsi or Wahab, up to this point? Okay, assuming no questions.
No.
Perfect, perfect. Let's disconnect here and connect back at 8 a.m. Bye-bye.